All right, guys, this is section 5.4 and 5.5, which deals with acid reactions in everyday life, so where we see them. And then 5.5 is all about alkalis. So if you ever had, you know, indigestion or acid reflux or headaches or something like that, those are all chemical imbalances in our body that causes some reaction to occur. So how we fix those are simple medicines, but stomach acid is basically hydrochloric acid, HCl, and we have things to neutralize it, like antacids, that have non-toxic effects on the body. Some are liquid, like milk of magnesia, which is magnesium hydroxide. Some are tablets, like Alka-Seltzer or Tums, that have sodium bicarbonate or baking soda, basically, and some soluble acid like citric acid. So you basically are adding Alka-Seltzer adds to water. You make carbon dioxide and helps kind of release that indigestion, and then also with a bicarbonate or baking soda, it helps release again CO2, and that's why you kind of burp when you have that reaction. Sometimes in cooking products, you have some calcium that are built up. A kettle or other products that have water in it, you have what we have is hard water, limestone areas that causes a calcium carbonate to form on these cooking vessels, and that's what also happens in other aspects, like um, a chlorinator for pools. You have this calcium buildup. So to help reduce calcium carbonate, we use vinegar or any other type of acid. Now we use vinegar or ethanoic acid or acetic acid because it's a weaker acid. So if we use something that's stronger, like hydrochloric, it could cause damage to the kettle or the vessel itself. So basically use some type of vinegar. This also is beneficial for uh, buildup of battery acid that corrodes the electronics. So sometimes you see that green or bluish color built up. You can use acetic acid to rub that off. That comes from the batteries. Toothpaste and tooth decay. So we always talk about the sugar in for cavities, and why does sugar give us cavities? So sugary foods have a higher pH, around 7, 6.5. And when you have bacteria in the mouth, it creates lactic acid or pH. So it lowers our enamel in our mouth. That causes the decay in our teeth to occur. So that's why you want to make sure you brush your teeth and get rid of that pH difference. So tooth decay occurs when you have a lower pH, 5.8. So that's going to destroy your enamel. So we have fluoride in our toothpaste to help raise the pH. So most things we try to lower the pH in our stomach, but in this case we try to raise our pH, and that's why also you're not supposed to eat your toothpaste, but it helps raise that pH so your enamel is not as intact. It helps neutralize the acid. All right, Aragon A ampite, they sting, especially if you have lots of them. That's because they produce methanoic acid. Um, they inject methanoic acid into your skin, and that causes it to itch and causes it to kind of rise up or give you like a little blister. We treat that with, again, base. So baking soda, if you use a little paste of baking soda or sodium bicarbonate, sodium hydrogen carbonate, it helps reduce the acidity. And calamine lotion, which contains zinc carbonate, does the same thing as well. All right, we love food. So we need to plant seeds, And what happens with pH of the soil causes things to grow too slowly or too wearily, or not enough acidity, not enough base, can cause the harm of the plant. So if something is too acidic, there's a lot of iron or sulfur in the areas. They call it high peat areas. And if you have too basic, you have more limestone, calcium areas. So Florida is more limestone. So you'll see a lot of pH that's higher than normal in Florida. So what we have to do is add some fertilizers or acidity to these basic solutions, or if you're acidic, you have to add some base to the soils. So how does pH change? Fertilizers or acid rain can cause these soils to change, and different plants prefer different conditions. So you have to make sure you know what plant you're growing and what the pH is optimal for that plant. So we treat acidity with lime or calcium oxide or calcium hydroxide, or just chalk, calcium carbonate. Anything that's a basic will help treat acid soil. If something is too basic, we add sulfur or some other decaying material like manure, peat moss can help lower the pH. Also, magnesium sulfate is used sometimes to help lower the pH. All right, wastewater treatment. So this is one of the most important things we don't think about every day because we drink it, we bathe in it, but it's important to have clean water. So solid waste, or liquid waste, sorry, is acidic. Okay, we have urea coming out of our bodies when we pee, and we have to make sure we add a base before it leaves, so we're not drinking acid water. And we don't want to make sure we lower the pH into our rivers, so we want to make sure we raise the pH to cause any other damage like bacteria growing or fish kills or reducing the oxygen levels. We want to make sure the pH is sufficient to help the wildlife. So if we don't, we have fish kills, or river life can be destroyed. So we have to add that slated lime to the streams and rivers to affect the acid part of the treatment centers. All right, last one we have is a scrubber. So why a scrubber is important? So a scrubber reduces the gas of nonmetals. So sulfur, nitrogen, carbon, all will produce oxides that make the rain acidic. So we want to make sure we reduce the number of carbon and sulfur and nitrogen into the air. So we have these scrubbers. So SO2 is one of the main ones because that creates H2SO3 or H2SO4. And again, we add a desulfurizer or something like calcium to help neutralize it before it leaves, so it won't cause any acid rain. All right, alkalis and bases. This is a quick review. You should already know most of this. But an alkali is a substance that dissolved in water will give you a pH greater than 7. Turns litmus blue, contains OH ions. It's soluble in water. So there's two different types. We talk about alkalis that are OH, and then everything else, bases are everything that causes it to turn blue. So it can be anything. So anything with a metal oxide or an OH metal is a base, and specifically alkalis are ones that are soluble in bases with OH. So it has to have OH to be an alkali, but is also considered a base. Common alkalis, sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide, all are soluble in water, and they all have OH. Neutralization reaction, quick review. Acid plus a base makes a salt in water. Majority of the salts we make are going to be soluble in water. Properties, they neutralize acids. The metal oxides make hydroxides. They're mostly soluble. Some of the bases are soluble, but mostly are insoluble in water. Most of the transition metals are not going to be soluble in water. Alkalis feel soapy. That's why they're cleaning products. They turn litmus blue. They give it pH greater than 7. They contain OH ions. Pretty basic stuff. Basic.